Okay, this is Unit 6, Lesson 11, Using Equations to Solve Problems. And our focus question is, how can you use tape diagrams, equation, and reasoning to solve word problems? Let's look at 11.1, Remember Tape Diagrams. So here we have a tape diagram, and number 1 says write a story that could be represented by this tape diagram. So as I'm looking at this tape diagram, I see that I have a total of 24 of something, and then up here I have a group of a plus 2, another group of a plus 2, and another group of a plus 2. So if I were to think of something I could make a story out of this, I could say Elena picked a total of 24 pieces of fruit, and she's going to give a bag of fruit to each of her 3 friends. So here is a friend, here is a friend, and here is a friend. And in each bag she put some apples, and then she added 2 oranges to each bag. So she put in some apples, the same number of apples in each bag, and then added 2 oranges to each bag for a total of 24 pieces of fruit. Number 2 says write an equation that could be represented by this tape diagram. Well, we know our total is 24. 24 is equal to, she has 3 groups of friends, and she gives each friend some number of apples plus 2 oranges. And each friend is going to get that much fruit, and she has 3 friends. So that's what our equation might look like for this tape diagram and this story. 11.2 at the fair. Tyler is making invitations to the fair. He has already made some of the invitations, and he wants to finish the rest of them within a week. He is trying to spread out the remaining work to make the same number of invitations each day. Tyler draws a diagram to represent the situation. So if we're looking at this tape diagram, we have 122 as a total. We have 1, 2, 3, 4, 5, 6, 7 of some number that we don't know, and then 66. Part A says explain how each part of the situation is represented in Tyler's diagram. So how many total invitations is Tyler trying to make? Well, we can see he's trying to make a total of 122. How many invitations has he made already? So this is our known amount. He's made 66 already. And how many days he has to finish the invitations? Well, if he wants to do it within a week is 7 days, so he has 7 days. Part B, how many invitations should Tyler make each day to finish his goal within a week? Explain or show your reasoning. So if we're using the tape diagram, this whole amount is 122, so if we take away 66 from the 122, we have 46 that he has to make, divided by 7 days. So 46, that's 12 minus 6 is 2. 42. So 42 divided by 7 days is equal to 6. So he needs to make 6 invitations each of these days. Part C says use Tyler's diagram to write an equation that represents the situation and explain how each part of the situation is represented in your equation. So our equation would be 122 is the total, and that equals 1, 2, 3, 4, 5, 6, 7 x's plus 66. So the 66 is the number of invitations he's made already. 122 is the total he wants to make. And 7 days in a week times some number of invitations. This is the some number of invitations he needs to make, and 7 is the days in the week. So how do we solve this? We would subtract 66 from each side. And we did that up here, right? So we end up with 7x is equal to 122 minus 66 is 42. Then we divide by 7, and x is equal to 6. Number 2. Noah and his sister are making prize bags for a game at the fair. Noah is putting 7 pencil erasers in each bag. His sister is putting in some number of stickers. After filling 3 of the bags, they have a total of 57 items. So here's the tape diagram showing that. And part A says, explain how the tape diagram represents the situation. So 57 is our total. And he's putting 7 pencil erasers and some number of stickers. So some number of stickers we don't know. We'll call that X. So here we have the pencils and some number of stickers, and we have 1, 2, 3 bags. Noah writes the equation 3 times the quantity x plus 7 is equal to 57 to represent the situation. Do you agree with him? Well, if I look back at my tape diagram, I have 3 groups of x plus 7. Some number of stickers plus 7 pencil erasers in 3 bags. So here I have some number of stickers plus 7 pencil erasers times 3 bags for a total of 57. So yes, I would agree with Noah. So I'm going to go ahead and solve this. 3 times the quantity of x plus 7 is equal to 57. So I'm going to use the distributive property here. 3 times x is 3x. 3 times 7 is 21. And that is equal to 57. So I want to get the x's by themselves, so I'm going to subtract 21 from each side of the equal sign. So I end up now with 3x is equal to 36. Divide by 3. Divide by 3. So 1x is equal to 12. So the x is the stickers, so she's going to put 12 stickers in each bag. 12 plus 7 plus 12 plus 7 plus 12 plus 7 is 57. Number 3. A family of 6 is going to the fair. They have a coupon for $1.50 off each ticket. If they pay $46.50 for all their tickets, how much does a ticket cost without the coupon? Explain or show your reasoning. If you get stuck, consider drawing a diagram or writing an equation. So I'm going to write an equation for this. They have a coupon for $1.50 off each ticket. And they pay a total of $46.50 for all their tickets. So I know their total is going to be $46.50. And I don't know the cost of a ticket. So I'm going to say X is equal to the ticket cost. And they get $1.50 off each ticket. So they pay for a ticket and they subtract $1.50 from that ticket. And since they're a family of 6, they're going to have to buy 6 of these. So that's what my equation would look like. They have 6 family members. They're each going to buy a ticket, but they get a $1.50 discount. So I'm going to use the distributive property here. 6 times x is 6x minus 6 times $1.50. 6 times 1.5 is 9. And that's going to be equal to $46.50. So they're buying 6 tickets and they get a discount of a total of $9. $1.50 off each ticket. So I'm going to add 9. I'm going to add 9. So 6x is so 6 tickets cost $55.50. So I'm going to divide by 6 to figure out what one ticket is. And one ticket would be $55.50 divided by 6. I'm just going to use my calculator. 55.50 divided by 6 is $9.25. So each ticket costs $9.25. Okay, let's look at 11.3. Priya, Han, and Elena are members of the running club at school. Priya was busy studying this week and ran 7 fewer miles than last week. She ran 9 times as far as Elena ran this week. Elena only had time to run 4 miles this week. Wow, there's a lot going on here. So we have some amount she ran last week. We have some amount this week. So let's see what she ran. She ran 7 fewer miles than last week. So Priya ran 7 fewer miles than last week. So some number minus 7, some amount of miles minus 7 is the amount that Priya ran. She ran 9 times as far as Elena this week. So this week she ran 9 times whatever Elena ran. Elena only had time to run 4 miles this week. So Elena ran 4 miles this week. So this week 9 times Elena, 9 times 4 is 36. So Priya ran 36 miles, a total of 36 miles, which is 7 fewer than she ran last week. So let's figure out how much she ran last week. So we're going to add 7 to both sides. So x is equal to 43. So she ran 43 miles last week. Part B says, Elena wrote the equation 1/9 times the quantity of x minus 7 is equal to 4 to describe the situation. She solved the equation by multiplying each side by 9, then adding 7 to each side. How does her solution compare with the way you found Priya's miles? So let's go ahead and solve this, and we'll go step by step. So 1/9 times the quantity of x minus 7 is equal to 4. So to solve this, we're going to divide each side by 1/9, or instead of dividing by 1/9, that really means to multiply by the reciprocal, right? 9 over 1. So we're going to multiply 4 times 9. And we can see that's what we did here, right? 9 times Elena. Elena was 4. So 9 times 4 was 36. So that's how we get that part. And then she added 7 to each side, which is what we did here, right? We added 7 to each side also. Okay, number 2. One day last week, 6 teachers joined 5/7 of the members of the running club in an after-school run. Priya counted a total of 31 people running that day. How many members does the running club have? So we'll say X is the members of the running club. And we know the total is 31 people. So 31 is going to be equal to, well, let's see. She counted a total of 31 people, and there were 6 teachers. 6 teachers joined 5/7 of the members. So 5/7 of the members, right? We're looking, of means to multiply. 5/7 of the members, plus we have 6 teachers, for a total of 31 people. So to solve this, we need to subtract 6. That'll give us a total of 25 is equal to 5/7 times x. So 25 is equal to 5/7 x. So we're going to divide by 5/7, but since we're dividing by a fraction, we're going to multiply by 7/5. And we're going to multiply this side times 7/5. So our x would be 7/5 times 25 over 1. So I'm going to cross cancel here. This would be 1 and 5. So 7 times 5 is 35. 1 times 1 is 1. So 35 over 1 is equal to 35. So 35 is equal to x, and that's the members of the running club. So the running club has 35 members. Okay, let's look at number 3. Priya and Han plan a fundraiser for the running club. They begin with a balance of -80 because of expenses. In the first hour of the fundraiser, they collect equal donations from 9 parents, which brings their balance to -44. How much did each parent give? So their balance being -144, that is what it's going to be equal to. So 44, or -44, is equal to what? Well, they begin with a balance of -80, and then they collect equal donations from 9 parents. So they're going to add to that -80 9 parents times some amount that they gave. So here's our equation. So to solve this, we're going to add 80 to both sides. So the 9 parents gave a total of -44 plus 80 is +36. So the 9 parents gave $36 total. If I want to find out what each parent gave, I divide by 9, and x would be equal to 36 divided by 9 is 4. So each parent gave $4. Number 4. The running club uses the money they raised to pay for a trip to a canyon. At one point during a run in the canyon, the students are at an elevation of 128 feet. After descending at a rate of 50 feet per minute, they reach an elevation of -472 feet. How long did the descent take? So if I were to write an equation for this, I know they're going 50 feet per minute, and they started out at an elevation of 128 feet, and then they finally reached -472 feet. So over here I'm going to write where they were, and here I'm going to write where they ended up. So they ended up at -472 feet. But how did they get there? Well, they started out at 128 feet, and then they went down, right? They're descending, so that means they're going down. They went down 50 feet per minute. And then they ended up at -472 feet. So I'm going to solve this. I'm going to subtract 128 from both sides. So that's gone now. Now they went down 50 feet per minute, and 472 minus 128 is, so if I look at this in a linear fashion, I got -472 minus 128. So remember subtraction, I could just do a keep, flip, change. So I'm going to add these two together and use the sign they have in common. So 472 plus 128 is 600. And I'm going to use the sign they have in common, so that's -600. So now I'm going to divide by -50 and divide this side by -50. So the minutes are equal to 600 divided by 50 is 12, and a negative divided by a negative is a positive. So it took them 12 minutes. Okay, let's look at our summary. What strategies can you use to solve word problems? So one strategy is to make an equation. And you could use a tape diagram or a hanger diagram. But we really want to get in the habit of being able to make these equations because we could solve them pretty efficiently with an equation. So one thing you want to do is you want to always find what the total is. That's going to be your equal. That's what your equation, what your expression is going to be equal to. So if we go back to the problem in our lesson today, a family of 6 is going to the fair. They paid a total of $46.50. So that's what our equation is going to be equal to. Are there any equal groups? If yes, use parentheses. If there's not, then you don't have to use parentheses. But in this case, there were 6 family members who paid for a ticket minus $1.50 off each ticket. So that's going to be our 6 equal groups. So now we're going to have 6 equal groups of a ticket price minus $1.50, and that's going to equal $46.50. And what are we doing? What's in the groups? Are we adding to something or taking away something? In this case, they get a discount, so we're going to be looking for those keywords. Discount. Descending was another one we saw today. That means subtraction. Taking away from, that means subtraction. Or are we adding? Are we adding to something? So look for those keywords also that mean to add to. So those words may be increased by or more than, combined. Those are the words meaning addition. And what's the unknown value? That's going to be your variable. So the unknown value in this case is the original price of a ticket. So our equation would be the total, $46.50, which is equal to six family members, and they each buy a ticket with a $1.50 discount. And this would be the equation we solved. And we did that earlier, so I'm not going to go through it again.